right, so today what we're going to do is we are still looking at applying properties of positive and negative exponents. We're going to do quotients. And quotients is just another word for division. Specifically, what we're going to be doing in here is fractions, where division is concerned. When we do this, I'm going to do the long way right now. When you do your homework, you do not do it the long way. But again, I hate to give students all these rules and they go, I don't get how you got that rule, like that makes no sense. Or you take your ACT test and you're like, oh man, how do I do this again? You'll be able to figure out what to do by doing this if you get stuck, okay? So let's take a look at this. I've got 6 to the 4th, which means how many 6s do I have? 4. I have 4. And you'll notice that there's multiplication between all of them.
Wait. Why is there 4?
Oh, sorry. You're right, it's a 6. There we go. And then down in the denominator, there's how many?
3.
So I got 6 to the 4th over 6 to the 3rd. Okay, now, remember in elementary school, you would reduce fractions. And hopefully, a lot of you don't remember because you didn't do the really cool sounds that go with it. Okay. Whenever I have multiplication going all the way across in the numerator and multiplication all the way across going in the denominator and they're the same numbers, I can cancel them. So I can go, wah, wah. One up above, one down below. One up above, wah, going down below. Okay? Or you can do like the sound. So you go, whoosh, whoosh.
You sound like the teacher after giving you trouble. That's
yeah, I'm kind of like the Wolverine. Okay? Yeah. When I do that, I've got 1 6 left over and it's in the numerator. And I'm done. That's it.
No, I'm not.
So what I'm doing is I'm taking something that you were supposed to learn probably in elementary school and applying to something that we're doing in high school. Okay? So now let's take a look at the next one. How many negative 2's are in the numerator? 8.
Good job.
And 3 in the denominator. I used to like to always write them out because then I got to cancel them out. It was kind of fun because they could do cool sounds. So you got 8 in the numerator. And you got 3 in the denominator. And then you get to, cancel them out. So here we go. Okay. So now, how many negative 2's do I end up with?
5.
I end up with 5 negative 2's. Okay.
That's all we have to do.
Well, so far, just breathe. I'm not done yet.
Oh darn,
It's gonna get harder. It has to. Math can't be done. Just don't say the answer yet.
Is this the one day thing?
Okay, this is a surprise. You guys are coming up with the answers and then you ruin the surprise for everybody. I'm like wrapping this pretty gift and you're like, oh, by the way, you're getting a Gucci monster. I've always wanted it. Alright. Now, I got 4 squared, right? So it's 4 times 4, right? And then times 6 all over. And then when I get done, I get to cancel. I end up with 4 to the Notice how even though I have that little star in between them, it doesn't affect what I'm doing. Also notice that the bases are the same. So I've got 4's going all the way across, in the numerator and the denominator. Now, this last one is what students tend to struggle with, and that's why I do it. You'll notice in the numerator, I have a 1 above y to the 9th. Do you see that? Underneath this y to the 12th, I also have a 1. It's kind of like if I have the number 5, I can write it as 5 over 1. We did it with slope. Okay? So the 1, if I multiply it by y to the 12th, does it change it at all? It doesn't. It's kind of like an extra. So in the numerator, I only have 12 of these. Did I do too many? See, I got y happy. I put too many. Okay, over how many? 9. Okay. And then I can cancel.
Good job.
So I get y to the 3rd. Notice that the 1s don't really do anything because it's just multiplication. Notice how multiplication and division they're related. They're like best buddies. Addition and subtraction are best buddies, so they kind of undo each other. But if there's any kind of addition here, that would change this problem. All right, this is the long way. This is not how you do your homework, but I wanted you to see how the rules work. Now let's talk about the rules. Here we go. If I have 6 to the 4th and I have 6 to the 3rd, what do I do to get 6? Yes.
Subtract.
Subtract what?
4 and 3.
The exponents, yeah. 4 minus 3 is 1, which gives me 6. 8 minus 3 gives me 5. Now, take a look at the next one. I got a 2 and a 6, that makes 8. And 8 minus 4 is 4. And then I got y to the 12th and y to the 9th, that becomes y to the 3rd. So I can subtract my exponents when the bases are the same. Okay, so let's take a look at this. The rule would be, I've got a 6, notice that it's top heavy, I got more in the numerator than the denominator. I take 4 minus 3, and I get 6. Now, I did a little bit of work there just to show you what the rule is. When you do your homework, this is actually what you're going to do. You're going to have negative 2 in parentheses. You're going to go, okay, 8 minus 3. There's how many more in the numerator? There's 5. So I get negative 2 in parentheses to the 5th, and I'm done. Because it's top heavy, there's more in the numerator. Okay? When you do this next one, what you're going to do is you're going to need to combine a little bit. So it's 4 to the 8th over 4 to the 4th. So you need to combine first, bring it together, and then subtract. So it's kind of like combining like terms when we had algebra. And then finally, this last one. Okay. I'm going to put y to the 12th over 1. And this is the one that students really mess up on because they forget to do this. You want to put y to the 12th over 1. 1 times y to the 12th is? Good. Y to the 9th times 1 gives me? Then you subtract and you get y to the? So you need that work. Bring it together and then subtract. Questions? So I make sure I have my work out while I'm doing it so I know exactly what to do. All right, let's go to the next property. I don't like the way these are written. It was really difficult to get my computer to do what I wanted it to do today. So when I do these, I would write them like this, where the R is on one space, the fraction bar is on the line, and then the S is in another space. So make sure that you use your lines and your spaces on your paper. I do one on top of the other. I wouldn't go sideways. And then parentheses and all of it's to the fifth. What we're going to do on these is we're going to distribute.
Is that a 5?
It's an S.
Or is it like where I top? That's a 5.
I put a line in the middle of it so you know it's an S, not a 5. Okay, so we're going to distribute. This becomes R to the fifth over S to the fifth, and I'm done. I can't go any further because they're variables. And again, these rules seem really, really easy at first, but when you combine them with a lot, it becomes more confusing. All right, let's take a look at this next one. You're going to notice that it's -4/3. So again, I'm going to rewrite it. Make sure you use the lines on your paper. Now, -4, I'm going to put in parentheses, but the 3, I don't have to. I could, but I don't have to. Why does 4 have to have parentheses?
It's negative.
Yes, because it's negative. Okay, and I can go further. -4 to the third is -64, and then 3 cubed is 27. And you go, well, Mrs. Medvick, how do I know when I should take it farther or not? Well, one of the reasons why I give you the answers to the problems is so that you know how far to take them on your homework. On a test or quiz, I will let you know. I will say take it as far as you possibly can. Okay. Question. All right, and then that is it for today. We've got day 2, and that will be tomorrow. All right, so you can go ahead and upload your book, and I'll get your assignment in just a few minutes.